Hey guys, so what we're going to do today is we're going to go over the Soldier System project. And what the Soldier System project is, typically the way we do it, it's usually one of our first projects in the year. Use a topic that you guys are familiar with, systems of equations, and kind of use this as kind of our first outdoor project-based activity. Right? So the Soldier System, just to kind of remind you of kind of how we do math. Number one, step one, we get information. Right? And information, right, in math, what do we call that? Data, right? We collect data, right? Step two, we build a mathematical model. And Courtney, what do we do that? What do we call that in math class? Equation. We create an equation. And then finally, what's step three, Ricky? Predict the future, right? So that's what we're going to do. We're going to do this reviewing systems of equations, which is a topic that you guys are all familiar with from your Algebra 1 class. So the first thing we're going to do, collecting our data. We are going to go outside. Right? We are going to run 25 yards. And we're going to time how long does it take each of us to run 25 yards. Right? Don't pull a hammy. Right? Just run. You don't have to run as fast as you can. But just collecting some data. How long does it take us to run 25 yards? Now, just let me ask you, Ricky, how long do you think it would take you to run 25 yards?
5 or 6 seconds.
Yeah, OK, so let's just kind of keep it simple. We'll just say 5 seconds, right? Now, the supply team, right? Supply team is going to be a few of you guys. They're going to be carrying all sorts of equipment. We're going to have a stretcher. We're going to have like big bags of sand. We're going to have duffel bags filled with equipment, right? And so this team, do you think they're going to run faster or slower than Ricky did? Definitely slower. Susie, how long do you think it would take the supply team to run the same distance, 25 yards?
Probably 10 to 15 seconds.
All right. Let's just to kind of keep the numbers simple. We'll just say 10 seconds. Right? So we would collect our data. You ran it in 5 seconds. Right? Of course, it will be different for each and every one of us. Right? Let's round to one decimal place to kind of keep it precise. Right? And the supply team, we'll just say for the sake of this, 10 seconds. Now, the supply team, we got one supply team in the class. Everybody will have the same data for that. Okay. So the next thing we got to do is we got to convert our data into yards per second. Now, if you're running 25 yards, right, how do you convert the time that it took you, right? How do you convert that into yards per second? What are you going to do? Ricky, what would you do? That's exactly right. So in our situation, it's 25 divided by 5, which would give us 5 yards per second. So you take the distance divided by the time that it took you. Now the supply team, right, Courtney, how long did it take the supply team? 10 seconds. So to come up with the supply team's rate, we would divide 25 by 10. Right? So what we've got, 5 yards per second is our speed. 2.5 yards per second is the supply team's speed. Let me ask you a question, Sasha. Who's faster?
You.
Yeah, we're faster. Obviously, we're not carrying all that stuff. But for the purpose of this activity, for the purpose of this race, right, we're going to give the supply team a 50-yard head start. So Jesse, if the race was a really short race, who would win?
Supply team.
Yeah, the supply team, because they get a 50-yard head start, right? Who would win if this race was like went on for 5 minutes? Who would win? You would, because you're going faster, right? So there's going to be a certain time when we would pass the supply team, when you would pass the supply team. And what do we call that? When you get a system of equations, the time when the two lines cross, what do we call that? What do we call it?
The y-intercept?
No, the y-intercept is actually the starting point for both teams. Yeah, that's where the two lines intersect, right? So that's one of the things that we're going to solve for. So anyway, I talked a lot about this. Right? Assumptions we're making here is that the supply team gets a 50-yard head start, right? That you and the supply team maintain the same speed for the entire race, right? I know that's an assumption, but that's an assumption that we're making, right? So now we're going to come up with our equations, right? So your equation, right? Your distance, all you're going to do, you're not getting a head start, so you're going to take your distance and you're going to multiply the number of seconds by what? You're going to multiply the number of seconds by your speed, right? So it's just going to be y equals your speed. In our case, it's 5 yards per second times x, right? So after 1 second, we would have run 5 yards. After 2 seconds, 10 yards, right? Now, for the supply team's equation, right, it's going to be y equals, right, the speed times the time, right? So 2.5 times x. But we're going to add something, right? The y-intercept, Sasha, that you said, right? Our y-intercept is just 0. We're starting at the starting line. But the supply team gets a head start of 50 yards. So what's the y-intercept going to be for the supply team? 50, exactly. That's exactly right. So once you come up with the equation, really that's the hard part, because once you do that, right, step 4 is to create your data tables. These are what your data tables look like. Right, so all you're doing is you're plugging in values for x, seeing what your values are for y. Once you complete your data table, you are going to plot your points and graph your lines. Right? And one of the things that may be a little difficult is how do you scale your graph? And you want to make sure that you scale your graph so that the lines intersect. One line will be starting at 0. One line will be starting at 50, and then they will cross. And then steps 6, 7, 8 are just answer a bunch of questions interpreting your graph, interpreting your data tables, and interpreting your equations. Do you guys have any final questions? All right. Let's get out there. Let's run some races. Let's carry some supplies, and let's have some fun. And remember, there's no better way to keep it real than with real-world algebra.